Red Bull's brand new 2026 engine just shocked the paddock and it hasn't even hit the track. Early dyno tests are breaking internal benchmarks, and engineers from rival teams are calling the numbers unnerving. It's their first ever full in-house power unit, built with Ford from scratch, and it's already outperforming expectations by a massive margin. Subscribe now, because if this engine is as fast as the data suggests, Red Bull might have just rewritten the rules of Formula One dominance. For the first time in Red Bull's history, they're not relying on a supplier. This 2026 engine is the product of a brand new division, Red Bull Powertrains, created specifically to tackle the most complex regulation shift in modern Formula One. Built in-house, paired with advanced electrification support from Ford, and overseen by a team of ex-Mercedes and Honda engineers, this power unit marks a total departure from their past, and it's already sending tremors across the paddock. Why the shock? Because early observers, including senior engineers from rival teams, weren't expecting Red Bull to reach competitive numbers this quickly. Developing a hybrid engine under the 2026 rules is notoriously difficult. The balance between combustion and electric energy must meet strict deployment windows, and weight limitations have squeezed design creativity. But according to sources familiar with the testing, Red Bull's unit is not only stable, it's reportedly generating smoother power curves than any rival's prototype so far. That alone would raise eyebrows. But what's really catching attention is the system's efficiency. The engine's electric components, battery, MGUK, and inverter are reportedly optimized beyond expectation. Ford has introduced advanced battery cell balancing and high-speed silicon carbide inverters, allowing for faster energy flow, tighter switching frequency, and minimal thermal loss. In practical terms, that means Red Bull can deploy electric power more often, for longer, and with less risk of overheating under race conditions. The ICE itself has also surprised engineers. Built from scratch under Red Bull's roof, the V6 unit is not just powerful but mechanically compact. This has allowed the team to repackage the rear of the car with a tighter Coke bottle shape and more aggressive floor geometry. The gains here are aerodynamic as much as mechanical. By minimizing engine volume and heat output, Red Bull has unlocked airflow advantages that feed directly into rear downforce and stability. The integration between engine and chassis is what sets this project apart. Unlike legacy manufacturers who adapt power units to fit various customer cars, Red Bull has designed this engine solely for its own aero philosophy. That means exact mass placement, optimized mounting points, and weight distribution that matches the suspension map of the 2026 chassis. From the beginning, the car and the engine have evolved together. This is not a plug-and-play system. It's a symbiotic machine, built for one purpose: maximum performance under new generation rules. Inside Red Bull's Milton Keynes campus, the dyno data isn't just promising, it's historic. Engineers close to the project report internal targets being exceeded ahead of schedule. More critically, durability testing has revealed minimal vibration anomalies or thermal spikes. That's rare at this stage of hybrid development. It points to a power unit that's not just fast, but reliable, an asset that could be crucial if rivals suffer penalties or component failures during the season. And now, the paddock is paying attention. No longer seen as just a chassis powerhouse, Red Bull has entered the engine arena with a fully independent program, and it's already competing with legacy giants. What was expected to be a learning year may now become a launch year. And if this early form continues into full car integration, Red Bull may be walking into 2026 not to adapt but to dominate from day one. Inside Red Bull Powertrains, engineers are not just testing for horsepower, they're measuring energy behavior under microsecond cycles, a level of granularity typically reserved for aerospace. Ford's influence has been crucial here. Drawing on its experience with electric drivetrains from both road and racing programs, Ford has implemented predictive thermal management algorithms that monitor and adjust battery cell load in real time. The system doesn't just wait for overheating, it prevents it proactively, giving Red Bull a major advantage in sustained deployment during race simulations. One of the biggest hidden breakthroughs has been in torque blending, the art of synchronizing electric and combustion torque across all throttle states. While most current systems struggle with sudden surges or dead zones in hybrid switchover, Red Bull's early testing suggests seamless transitions. Their MGUK doesn't just activate, it aligns with ICE behavior down to the millisecond. This means smoother corner exits, reduced tire wear, and more predictable handling, all of which contribute to lap time consistency over long stints. Ford has also introduced a next-generation inverter array using silicon carbide modules, which switch faster and generate less heat. Most teams are still using silicon-based tech developed during the previous hybrid era. Red Bull's system, however, handles energy spikes more efficiently and reduces conversion loss under peak load conditions. That translates directly into better electrical efficiency, and in this regulation cycle, where electric power must match combustion power in overall output, that edge matters more than ever. Another technical area where Red Bull has jumped ahead is in cooling architecture. Instead of traditional multi-radiator layouts, they've tested a zone thermal system with asymmetric airflow channels that direct cooling where it's most needed without compromising rear aerodynamics. Early wind tunnel models indicate that this has allowed them to reduce cooling inlets, freeing up volume for tighter side pods and less drag, advantages that translate directly into qualifying pace and fuel efficiency. Few outside the factory know this, but Red Bull is already operating a full rear-end test rig combining the 2026 suspension, gearbox, and power unit in live conditions. While other teams are still separating subsystems in bench tests, Red Bull's engineers are tuning how the engine's torque pulses affect gearbox harmonics and tire response under simulated G-forces. That kind of systems-level testing isn't normally seen until the final months before launch, yet they're doing it now, giving them time to refine rather than troubleshoot. Perhaps the most quietly revolutionary part of the engine is how it interfaces with vehicle dynamics software. Red Bull's development team has built a closed-loop simulator that doesn't just feed inputs to the car, it feeds feedback into the engine. The software adjusts deployment strategy live, based on virtual tire degradation, real-time fuel mass flow, and predicted sector demands. This engine doesn't just follow orders. It interprets race data and optimizes power in real time. It's not AI, but it is very close to adaptive intelligence. And while Red Bull remains secretive about peak numbers, one leaked document reportedly confirmed the power unit has already reached over 870 horsepower in early hybrid deployment simulations without breaching fuel flow limits or ERS caps. That number, if confirmed, puts them at the upper edge of the performance curve before any rival has even finished track mapping. And with testing regulations tighter than ever, having that head start in both software and hardware could prove to be the most valuable advantage in the first year of F1's next hybrid era. Red Bull's 2026 engine is not simply an evolution of what came before, it's a structural redefinition of how a power unit lives inside a Formula One car. Instead of designing the engine and then shaping the chassis around it, Red Bull reversed the process. The aerodynamicists defined the space first, then the engine team built within those constraints. That flipped approach has resulted in a more compact, more efficient layout that directly supports the car's low-drag design philosophy. Every gram saved in packaging has been reinvested in aero efficiency, and every centimeter reclaimed in volume is now being used to extract airflow gains. One of the boldest changes lies in how the new engine coexists with the rear suspension structure. Red Bull's 2026 architecture uses the engine block not just as a power source, but as a load-bearing element in the car's mechanical design. The torque arms and suspension mounts are directly aligned with the stiffest areas of the power unit casing, improving load transfer while reducing unwanted flex. That gives drivers sharper turn-in response and more consistent balance mid-corner, two traits that become essential as downforce is redistributed in the new regulations. The battery, meanwhile, has been repositioned along the car's centerline for better weight distribution and heat management. But it's more than just a physical relocation. Red Bull and Ford have implemented a zoned battery management system that allows selective discharge and recharge depending on circuit demand. In essence, the battery prioritizes energy flow to parts of the lap where maximum traction is required: long exits, steep inclines, and high-speed straights. The system does this automatically, based on live telemetry, meaning the car optimizes itself as it drives. Cooling remains one of the biggest challenges under the 2026 regulations, but Red Bull appears to have created a dual-phase cooling circuit that separates low and high-temperature zones across the power unit. This strategy reduces thermal bleed, allowing critical systems like the MGUK and inverter to operate at peak levels for longer. It also simplifies the airflow requirements, freeing up space for aero channels that improve rear downforce. While other teams have widened their radiators or compromised bodywork shape, Red Bull's solution preserves both performance and packaging, a rare feat under hybrid rules. Another major leap has come in vibration damping, particularly under electric to ICE transitions. Ford engineers, drawing on experience from high-performance EVs, developed a micropulse damper system that sits between the crankshaft and energy recovery unit. It filters out harmonic noise and torque ripple, making power delivery smoother at low RPMs and more stable during partial throttle. The benefit for drivers? Better traction in high-load corners, less tire chatter, and more confidence on exit, all without needing electronic traction control. Perhaps most impressive of all is how Red Bull has compressed its entire powertrain development cycle. Instead of waiting for parts to complete bench testing before virtual simulations, Red Bull has merged the two processes. Hardware is tested while being modeled in real time by digital twins that adjust simulation parameters based on actual behavior. This feedback loop dramatically shortens development time and allows the team to fix issues weeks before they would have even appeared in traditional pipelines. It's an efficiency weapon disguised as a research tool. All of this contributes to one undeniable truth: Red Bull hasn't just built an engine. They've created a high-speed, low-drag ecosystem where every subsystem, mechanical, thermal, electronic, aerodynamic, is in sync. This is engineering at the edge, where performance isn't just extracted, it's anticipated. And if what we're seeing now holds up through track testing, then Red Bull won't just be ahead in 2026, they'll be setting the pace that others will spend seasons trying to match.